Okay, so we're solving equations with addition and subtraction. We're looking at linear inequalities, solving with either addition or subtraction at this point. We'll find that it's pretty similar to solving equations with a couple small wrinkles. We'll also introduce something called set builder notation, which is the way we'll be expected to write our answers getting ready for us for next year. So again, as I stated earlier, very similar to solving equations. Big difference with an inequality is that we have one of the four inequalities below rather than having an equation with an equal sign. So that's the main difference between an equation and inequality. As we start working with multiplication and division of positive and negative numbers, we'll notice a couple other issues as well, but today that doesn't pop up. This is a table that's directly from our book that you may want to copy down. It's on page 296, or at least know where it is so you can reference it. That way, as we're writing out verbal expressions or using verbal expressions and putting them into numerical expressions, we know what different phrases like at most refers to. So again, I don't want to spend a lot of time on that, but you can find it in your book and copy it down. So when we're solving by addition, again, the goal is to isolate the variable on one side. To do this, we need to get rid of the negative 45. We can add 45, add 45. If you want to think of this as a river problem, it essentially is. And we get t on one side, 58 on the other, and we need to keep the inequality. If I were to graph this, pardon me, just sketch a rough graph, we'd have 57, 58, 59. And again, keep in mind that the number lines continue on and on in either direction. So we can read this as t is less than or equal to 58. Because of this particular inequality with the equal part, we have a solid circle at 58, and it is anything that is less than, so our shaded area needs to go to the left. In the next one, m minus 8, again, we need to isolate m, so we can go ahead and add 8 to both sides of the inequality. We end up with 30 is greater than m. If I have this, I know I have 29, 30, and 31. There's an open circle at 30. So if 30 is greater than m, we can also write this and reverse it or read it backwards. M is less than 30. In this case, our arrow goes to the left again. Continuing on, these two problems we need to solve using subtraction. We might notice that I have variables on both sides, so I need to move the variables to one side of the equation. We can subtract 5c, subtract 5c, and that will leave us with 7 is greater than c. Again, some of us like to rewrite it as c is less than 7. We don't need to, but certainly can. At that point, we have a number line, 6, 7, 8. Circle C, just change colors, it tends to show up better. Sometimes using a pen or a highlighter on your assignments makes this easier. So C is anything less than 7. On the next one, again, trying to isolate all the h's to one side. So if I subtract 4h, subtract 4h, we end up with h is less than or equal to 12. 11, 12, 13, just sketching a rough graph of this. Closed circle at 12, and h is anything that is smaller or to the left of that. Again, all these examples happen to go to the less than side or less than equal to side. Your assignment won't necessarily work that way. Okay, solutions to inequalities can be written in set notation or they can be graphed. We have been graphing them. Again, the inequality, when we graph them, will tell us if we have a solid circle or an open circle. And we can review that if we need to It was introduced in pre-algebra. When we use set builder notation, it will look like this, and we can discuss it some in class, but ends up being read as t such that t is greater than or equal, or greater than 0 in this case. So we'll go ahead and answer some of these using set builder notation. At this point, hopefully we see we add 5, t is greater than or equal to 12. If I were to graph it, close circle, okay, in set builder notation, we'd say t such that t is greater than or equal to 12, and we're basically rewriting our answer. -4 on this next problem, trying to get there and isolate that. 5 less than b, and we can write this b such that b, and I'm going to write it with the variable on the left, is greater than 5. And that piece is new as of this year. Okay, and we get to put these into word problems, which, again, it's taking basic knowledge that we have and trying to expand on it and deal with real-life situations. So the temperature T in a swimming pool increased 4 degrees since this morning. The temperature is now less than 81 degrees Fahrenheit. So we know the temperature is less than 81 degrees. Now we need the left side of this inequality. The temperature T in a swimming pool increased, that's addition, 4 degrees. So now we have an inequality. They ask us to solve it. We can subtract 4, and we get T is less than or equal to 77. If I put this into set builder notation, again we just go T such that T is less than or equal to 77 degrees Fahrenheit. So any temperature that's at 77 degrees or below would satisfy this inequality. Okay, here we have a little different scenario. Somebody's shopping for jeans. They have $65. They buy a t-shirt that's 18, a belt for 16. They're still wanting to buy jeans and need to know how much they could spend on the jeans without going over their $65. So in this case, they could spend up to $65 or anything less. So we could go less than or equal to $65. And then we have the t-shirt that's $18, the belt that is 14, jeans that is an unknown quantity. 18 and 14 combined to 32, so we simplify that and we get 32 plus j is less than or equal to 65. We can go ahead and subtract 32 from both sides, and we get jeans need to cost $33 or less. So if we write this out in the phrase, he can spend $33 or less on the jeans. This next instance, a number is decreased by 8, is at most. Might be helpful to look at page 296 to see what we do with that particular one. A number, we'll use n, decreased by 8. That part's fairly straightforward. At most 14. So in that case, it's less than 14. Now we're just solving, and we get n needs to be less than 6. Hold on, I'm adding 22. Okay, and put it into set builder notation so that this becomes something we're comfortable with as we move forward with math. Twice a number is greater than, so 2n is greater than -5 plus the number. Again, trying to isolate the variable. In this case, we need to subtract n, and we end up with n is greater than or equal to -5. Place that into set builder notation, and our final answer is n such that n is a number larger than or equal to -5. So that wraps it up for today. Hopefully it goes well. We'll see you on Monday.